Okay, this is going to be a quick review of Linux and some of the commands we've learned about so far. So let's go ahead and log into the CS server. Okay, the ls command lists out the contents of a directory. ls with the -l option lists out detailed information about the contents of a directory. Okay, if you don't provide an argument, it assumes the current working directory. So we didn't add an argument here. But I have a homework 2 folder. So if I type hw2, that's going to give me the contents of that folder. Okay? You can change directories with the cd command. So I can cd into homework 2. Type ls -l, right? cd to the tilde character, that's a shortcut for home. I can cd back into homework 2, and another way to get back home is to go up one level to the parent directory. cd .. That's the parent. -l. Okay, I'm in my home directory. I know that because if I type pwd, that's print working directory. It is not the password command. That changes your password. pwd print working directory. It is the current directory your terminal shell is working in at the moment. This is the absolute path to my home directory. The absolute path starts from the root of the file system. In Linux and Unix, that's /. In Windows, that's usually C:\\. In Windows, all the directories are separated by backslashes, but in Linux, it's /. It's unfortunately terribly confusing. Alright, so print working directory will always tell you what directory you're in. I go cd homework 2, print working directory. See? cd home. I can also do the password command that changes my password. passwd. Password. Type in your old password. New password. Oh, I just put in the same one, so I have to change it to something. Okay, it changed, so I'm going to change it back. Noticed as I typed, there were no placeholder characters, no asterisks when I typed a character in the password prompt. It's confusing at first for some people, but it's a security thing, so you don't know how many characters a user password is. But you could technically probably tell by counting the keyboard clicks that I'm making. But anyway. Alright, what else do we have here? Let's see. Absolute path we talked about. Okay, relative path. So let's talk about the homework 2 directory. Okay, right now I'm in my home directory and it's a child of my home directory. So the relative path from my current directory, that's the absolute path to it, the relative path to homework 2 is just homework 2. Okay, cd homework 2. I type in a relative path, and now I print working directory, and I see the absolute path includes the hw2 at the end. Okay, so relative paths are they're always relative to another location. Absolute paths are relative to the root of the file system. Okay, so you could have any number of relative relative paths to a particular directory or a file. It just depends on where you're starting. So if I change directory to the root of the file system, ls-l, then the relative path here is u1 cd u1. Notice it doesn't start with a slash now because it's a relative path. I just happen to be in the root of the file system. Class cs151 00/hw2. Print working directory. Okay. So any directory structure you make, since I'm in homework 2 here, ls-l, I can look at the parent directory, which is my home directory, and see what's in there. Now let's say I want to look at my public HTML, the contents of that. So I'm still in homework 2, print working directory. Okay, see, I'm still in homework 2, ls-l, a relative path to public HTML from where I am is go to the parent and then go to public HTML. Okay, so that shows you the difference between relative and absolute. Okay, let's back to the home directory. Another nice command, if your terminal gets too cluttered, you can type clear. There we go, I can breathe again. Alright, there are 3 ways to make files that you should know about. First one is the easiest. It's using a text editor like Pico. There are multiple text editors on the Linux system, like Nano and Mate, I think. We type in the text editor command Pico, and then the file name of the file you want to create. Here's some text from Pico. Control O saves. Control X exits Pico. If I type ls-l, there's file name. Okay. The cat command will show the contents of that file on the terminal screen. So cat file name. There you go. Now the second way to create a file is with the touch command. The man pages for touch basically just allow you to change the recently accessed timestamp on the file, but it also creates a file if it doesn't exist. So touch and then file, let's call it touchfile.txt. ls-l. We see we have touch file in there. If we cat touch file, there's nothing in it because touch, all it does is create the file. If I open Pico with touch file, open touch file with Pico, it's empty. Okay. The other way you can create a file is with the echo command. Okay, so the echo command echoes whatever arguments you provide it to the command line. It has one additional feature that will allow you to determine system variables. It outputs the contents of system variables if you reference them in the string as well. So I'll show you that in a second. But this is a simple way to create a file with echo command. So what's in the quotes here is the first argument. If I didn't have quotes around it, echo here would be the first argument, created would be the second argument, this would be the third argument, and so on. Since I have quotes around it, the entire thing is just the first argument. Okay. The greater than character here is telling Linux, take the output of this command, everything before it, and output that to a file named this. Okay, so echo is not the only command you can use to create a file like this, but it's convenient. So if I cat echo file, There you go. Who am I? It tells you what user you're logged in as. So I can do who am I? Who am I.txt. Notice I'm using the greater than sign again to create a file, just like I did with the echo command. Okay. Notice there was no output this time. It's because the output, instead of going to the terminal, went to the file. So cat whoami.txt, there it is. Okay. Alright, the echo command, as we mentioned, prints out whatever you provide it as an argument to the terminal screen. Okay, so echo I am here, there we go. You can also interpolate the variables of the system. So there's built-in variables in a Linux system. One of them is user. So I am user, and it's to reference the variables, it's a $ and then the name of the variable. I am user CS15100. Okay. There's also path. These are paths to the commands that you can reference from the terminal. Okay. So that's one benefit of echo. You can print out additional system variables. Okay. So that's echo. Another important command is copy. Hang on, let's clear things. ls-l. Alright. So let's look at our echo file. Let's copy that to echo file 2. ls-l. Now we have echo file 2. If we cat echo file, we see that's the contents of it. If we cat echo file 2, it's the same contents because the file was just copied. Now the move command does not duplicate the file. It just changes the name of it and moves it to a new location. So if I move echo file 2 to the same directory but use a different name, then it's like a rename command. Okay, so echo foo.txt ls-l. See, there's no echo file 2 now. It moved to echo foo. Cat echo foo.txt. Alright, so that's the move and copy commands. You can make a directory. So I'll make a directory called Linux demo, ls-l, and here we have Linux demo. ls-l, I'll provide it the argument Linux demo. There's nothing in there. Okay, so I'm going to move echo file in there to Linux demo, ls-l. Alright, so that moved. We have echo foo. I'm going to move that in Linux demo. I'm going to move file name in Linux demo. Okay, so I should have 3 files in here. And let's check inside Linux demo and see if we have anything in here. Yeah, we got 3 files in here. Got 3 files in here. And if we look in our home directory, we have the who am I and the touch file I created. Okay, so that's just moving things around. But But it's important, if you create too many files, you have to be able to remove them somehow. The remove command can be dangerous, so be careful when you're using it. Make sure you've typed things correctly. Alright, so rm touch file should remove touch file from our home directory. Yep, we remove whoami.txt. Now we remove the directory Linux demo. Okay, if we just type rm and Linux demo, it says it cannot remove it. It's a directory. That's a safety issue, so you don't remove a whole bunch of stuff accidentally. So do rm-r, no space. That is a command option. It stands for recursive. So it recursively goes through the directory and deletes everything inside of it. rm-r, Linux demo, ls-l, it's gone. Okay, so that's basic tutorial of the commands. One more is the man command. It stands for manual pages. If you ever need to look up what a command does, type in man. So man touch, for example, that was a new one we talked about, changes the file timestamps. It also creates a file. Okay, so that stands for manual pages. And then the chmod command changes permissions. We talked about that. So chmod homework2.txt. Well, first let's look at it. Oops, 2.txt. Okay, see, the permissions are just read for other users. Okay, so I can make it write and execute with chmod. So let's do chmod 777. That's my dog whining. Sorry. homework2.txt. Okay, so that should give everybody read, write, and execute permissions. Type ls-l homework2.txt, and sure enough, we've got read, write permissions here. Okay, I can chmod that back to 755 homework2.txt. So the 5 is just read and execute. You can't modify it, which is good. I don't want people modifying my stuff. If you want to lock down your directories, which I recommend you do, so any of your homework directories, you're going to use chmod 700. So that gives you full access, read, write, execute. That's the 7. 0 means your group. Nobody in your group can access anything, and no other users can access anything. So you would make that homework 2. Like that, ls-l. We see homework 2. I'm the only one who has access. No group permissions and no user permissions, or no other permissions. Okay, I can change that back to 755 homework 2 ls-l, and there we go. We got group has read and execute, and user has read and execute. Okay, that's a basic review of all the Linux stuff we've learned so far.